We have officially started Unit 6, which is our fraction and decimal unit. This is a very large unit for 4th grade. We started it last week and it will go until mid-April, so it's a pretty big piece of our curriculum. I'm going to be sharing some videos throughout the unit just so parents are comfortable with some of the strategies that are being taught in class. But last week our main focus was on equivalent fractions, and in order to find equivalent fractions, the kids noticed that you can multiply or divide fractions in order to find equivalent fractions. We really focused on reducing fractions to lowest terms because on the integrated test, a lot of times the answer is in a reduced form. So if the child were to get on the integrated test and they were to add two fractions and it gave them 10/12, 10/12 may not be one of their answer choices. They would have to apply their knowledge of reducing a fraction and reduce 10/12 to 5/6. So we've really been practicing that. So this week, today, Friday, and into next week, we're going to be doing comparing fractions. So I just kind of wanted to go over a couple of strategies that we're going to be using in class just so you are aware of what we're doing. So the first one is when the denominators are the same. Kids typically do really well with these types of fractions when you're comparing them. For example, 5/6 compared to 1/6. Students are aware that it's out of the same whole. So it's out of 6 pieces. So they know that obviously 5/6 is larger than 1/6 because you're only 1 piece away from 6 here versus here you're 5 pieces away. So kids typically do really well when looking at fractions with the same denominators. Then you have fractions where your numerators are the same. And with this strategy, I still use my denominator to help determine which one is larger. For example, if they were to shade 3 out of 9, you are 6 away from your whole of 9. Whereas here, if you were to shade 3 out of 4, you're only 1 away from your whole, even though they have different denominators. So 3/4 would be larger than 3/9. Another thing I tell the kids is think opposite. If your numerators are the same, it's actually the smaller denominator that's larger because you have fewer pieces to get to your whole. But kids typically do really well with 1 and 2. Then I introduced them to least common denominator, how to find that, because sometimes you have fractions where your numerator and your denominator are different. So they have to find that common denominator that these fractions have with each other to then be able to compare. And kids can utilize their knowledge of equivalent fractions in order to figure this out. That's why we teach equivalent fractions first, because really when you're finding the least common denominator, you're finding an equivalent fraction that has the same denominator, and then you can compare. So how to find that? For example, if you had 2/7 and you're comparing it to 3/8, in order to find your LCD, your least common denominator, we look at our denominator and we find its multiples. So you'll notice all of the multiples coming up to 7, some of the multiples coming up to 8, and we're going to circle what it has in common. And it has a 56 in common. So how I show that is I set it up as an equivalent fraction. For example, 2/7, I'm now changing it to a 56. 3/8, I'm now changing it to a 56. The students are aware that in order to find that equivalent fraction, they're going to have to multiply to get there. So 7 times 8 is 56. 2 times 8 is 16. So 2/7 is equivalent to 16/56. I do the same thing here with 3/8. 8 times 7 is 56. Therefore, 3 times 7 is 21. So 3/8 is really 21/56. They're equivalent fractions. So now that they have the same common denominator, I can compare. And when I look, 3/8 is going to be larger than 2/7. Another example of this is if I had 5/9 and I had 7/12. Again, I'm going to look at my denominators, 9 and 12. I'm going to find some multiples of 9, some multiples of 12. I recognize that they have that 36 in common. So that's what I'm going to multiply to. I'm going to find an equivalent fraction where they both have the same denominator of 36. So 9 times 4 is 36. 5 times 4 is 20. 12 times 3 is 36. 7 times 3 is 21. So you can see how close these two fractions really are. So when I look at them, 2036 compared to 2136, again, it makes 7/12, a little bit bigger than 5/9. When you're also looking at least common denominator, another trick that I taught them is, for example, if you had 10/21 and you're comparing it to 2/7, you know, before we start getting crazy with all of our multiples, first check to see if the larger denominator out of the two actually could be the one that you used as your common denominator. And the kids today were really excited about these because then they recognized that yes, 21 would work. I don't have to go through all those multiples. I can leave 10/21 the way it is, and all I had to do to 2/7 is to multiply to get to 21. So 7 times 3 is 21, 2 times 3 is 6. Therefore, 10/21 is bigger than 2/7. So sometimes they don't have to go through finding multiples for both denominators. Sometimes the larger denominator actually is that common denominator that can be used for both. So these don't take as long as the other two that I just showed you. Next week, I'm also going to show them a strategy. I did not introduce this today, but I will show it next week, called benchmarking fractions. Our benchmark fractions are 1/4, 1/2, and 3/4. And, you know, kids will get to a point where they can kind of utilize these three benchmark fractions on a number line to be able to kind of plug in an order for comparing fractions. And they're going to apply the skill of equivalent fractions, reducing fractions, to be able to do it. So, for example, if I have these three fractions here, 5/8, 2/4, and 2/3, and I have my number line, I have my benchmark of 1/4, 1/2, and 3/4, I'm going to look at 5/8 first. Well, I know that 1/2 of 8 is 4. So 4/8 would be 1/2. This is obviously a little bit bigger than 1/2. That's why I'm going to plot 5/8 after the benchmark of 1/2. I also know, with my knowledge of reducing fractions, 2/4 is the same thing as 1/2. So I can mark 2/4 right there on the half mark. And then 2/3, well, 2/3 is one away from the whole. So when I look at my benchmark of 3/4, the reason I could put 2/3 slightly in front of 3/4, even though they're both one away from its whole, 3/4 has more total pieces, which makes it a larger fraction. So that's how I know to plug it in front of 3/4 and not after 3/4. So then when you look at it on a benchmark number line, your order would be 2/4, 5/8, and 2/3. Another example of benchmarking would be if I had 2/6, 4/5, 4/6. So for example, 2/6, they'll use that knowledge of reducing and realize that 2/6 is really the same thing as 1/3. Well, if I'm looking at my benchmark fractions, 1/4 and 1/2, where would I place 1/3? You're going to place it after 1/4 because 1/3 is greater than 1/4. That goes back to that same numerator strategy that I showed. So they'd put it here. 4/5. 4/5 is one away from its whole. So if I look at the benchmark fraction 3/4, where would I put it? I would have to put it after 3/4. Again, because both of these are one away from the whole, the reason this one is larger is because it has more total pieces. And then 4/6, a student may recognize that 4/6 is actually 2/3. So where would I plug it? I would plug it before 3/4 because even though, again, it's one away from the whole, this one here, when I reduce it, 2/3 has less total pieces than 3/4. So when I benchmark it, my order would be 2/6, and then 4/6, and then 4/5. Okay, so that's just another little strategy that the students can use. So again, there's lots of different ways that kids can compare fractions. Some kids are just visual learners, and honestly, they can just look at the fraction and they can tell. But the strategy that will definitely make sure that they have it correct by using equivalent fractions and finding common denominators would be an LCD. but these are just some examples of what students can do in order to compare fractions. So I hope this has been very helpful. I'm sorry it was kind of long, but hopefully you'll be able to kind of see some of the stuff they're doing in class. Thanks.